Welcome to the Informed Woman magazine, where science meets clarity and knowledge becomes strength. I'm William Bologna. Let's make women's health understandable together.
What if the next medical revolution didn't come from chemistry, but from nature's oldest predator? A virus, not the kind that makes us sick, but one that hunts the very bacteria threatening our survival. These are bacteriophages, or simply phages, the viruses that could save us. For decades, antibiotics have been our shield, invisible, powerful, and taken for granted. But the bacteria have evolved. Every dose, every misuse, every incomplete treatment has taught them how to fight back. Today, antibiotic resistance kills over 1 million people every year, a silent pandemic growing in the shadows. The question and global health emergency is no longer if antibiotics will fail, but when. The story of phages begins more than a century ago. In 1917, French-Canadian microbiologist Félix de Herelle observed something extraordinary, an invisible agent that could make bacterial cultures vanish overnight. He called them bacteriophages, meaning bacteria eaters. But as antibiotics took the spotlight in the 1940s, phage research faded into obscurity, kept alive only in a few Soviet and Georgian labs behind the Iron Curtain. A phage is not alive in the traditional sense. It's a microscopic syringe, a genetic code wrapped in protein armor. It lands, injects its DNA, and turns the bacterium into a factory for its own kind. Within minutes, the cell bursts open, releasing new phages to continue the hunt. Each one is exquisitely specific, designed by evolution to target a single bacterial strain. Precision warfare. For decades, the West ignored phages. But as antibiotic resistance surged, the scientific community began to look backward and rediscover a forgotten miracle. Today, clinical trials from the US to Europe are exploring how phages can rescue patients for whom every antibiotic has failed. Each success feels like something ancient waking up again. In practice, phage therapy means matching the right virus to the right infection, a biological sniper for a bacterial target. Sometimes doctors use phage cocktails, combining multiple phages to widen their attack range. They can be applied on wounds, taken as capsules, or injected directly into the bloodstream, depending on where the infection hides. In trials, these treatments have cleared infections that antibiotics couldn't touch. But the frontier doesn't stop at natural phages. Using tools like CRISPR, researchers can now edit phage genomes, removing harmful genes, adding helpful ones. They can reprogram these viruses to carry enzymes or genetic payloads that disarm bacteria from within. Imagine a virus that doesn't just kill, it teaches the bacteria to self-destruct. The implications are extraordinary. Phages could one day clean wounds, sterilize surgical implants, and protect crops from bacterial decay, all while preserving the balance of healthy ecosystems. They offer something antibiotics never could: adaptability. When bacteria evolve, phages evolve faster. They are living algorithms, rewriting themselves to meet the threat. Yet even miracles demand caution. Phages must survive the human immune system, remain stable in storage, and meet rigorous safety standards. And because every infection is unique, no two phage therapies are ever the same, raising questions about regulation, standardization, and access. Are we ready for personalized viral medicine? Or will bureaucracy slow the cure before it arrives? Life has always found a way to balance itself: predator and prey, attack and defense, creation and decay. The war between bacteria and phage has been raging since the dawn of time, invisible yet essential. We are not creating something new. We are joining an ancient conversation between life and its own limits. In the age of resistance, survival may depend on humility, on learning from the smallest architects of balance. The viruses that once terrified us may yet be the ones that heal us. Because in the end, nature doesn't choose sides. It only seeks equilibrium.
Thanks for watching another video by the Informed Woman magazine. Please feel free to comment and ask questions. Subscribe for more science-driven medical insights.